I need to say something that is going to be controversial so that it's a viral moment on YouTube, you know?
Can you tell me, what do you mean when you say functional program?
For me, the most important one are the abstractions that function programming gives you. Things like higher order functions where you can pass one function as the argument to another function, or you have functions that return arguments.
What's going to be on the backside of your book?
The quote that I recall, which was after the book was published, was by Jason Turner.
Welcome to The Curious Developer. I'm Jesper Pedersen from KDAP, and today I have one of the brightest kids of our generation with me, Ivan Čukić, who taught me how to pronounce his name, which accordingly to himself should be easy, not for a day. But nevertheless, he is also Mr. Functional Programming in C++. And don't get me wrong, I have written more Emacs code in Lisp, have forgotten enormous amount of closing parentheses, more than you have put semicolons after your namespaces. So I know quite a bit about functional programming. So I'll just be holding the microphone for you here because I obviously know it all. Maybe. Ivan, do you ever feel like an unbalanced parenthesis when you walk around in a C++ crowd and you talk about functional programming?
So, hi Jesper, thank you for inviting me. I wouldn't say so. People in C++ community, at least people that come to conferences, quite like the idea of functional programming even if they're not using it that much. And people who don't care about functional programming, they don't realize that they are using a few things from the functional world.
So you wrote a book back in 2019, right?
Something like that.
Yeah.
To be honest, I have no idea when it was because it was written it was finished a year before it was published and the publishing was really slow.
Okay, so this book is from when the dinosaurs was roaming the earth. That was the time it was written. Does it have any relevance these days?
So I know that you're trying to bait me.
No, I wouldn't do that.
I'll obviously say, of course, it's relevant. If I didn't, I would breach my contract with the publisher. But yeah, I would say that some things have changed in C++. We got ranges in the standard. I'm covering the range v3 library by Eric Niebler in the book, and something's changed in between. But the core ideas and the core concepts that I focused mostly on instead of being a reference to some C++ feature, they're still valid and I expect them to be valid for decades to come.
Just tasting here, functional programming, that sounds like schema, like Lisp, like why C++?
That's another good question because
Thank you very much. Did you get that? Can you just repeat it for the audience here?
Okay, this needs to be cut, right?
Nope.
So, why functional programming in C++? I fell in love with C++ a long time ago. And at some point I started investing my time into Haskell. So to show that I'm younger than you, I mentioned Haskell and you mentioned Lisp and schema. And I realized that many of those things can be applied in C++ and make C++ code, let's say, more advanced, more readable and more safe.
There might be a single viewer out here for whom it's not super clear. When you say functional programming, is that just like a function? We have had that in C since, I don't know. Can you tell me, what do you mean when you say functional program?
So there is a saying that if you ask two functional programmers what functional programming is, you're going to get 3 different answers. And I would say that's really, really true. The things that I consider functional programming maybe other people wouldn't agree. Most of the people would say it's about functions, pure functions, where for one input you always have the same output, you don't have any mutable state and so on. For me, that's just one of the facets and not the most important one. For me, the most important one are the abstractions that function programming gives you. Things like higher order functions where you can pass one function as the argument to another function, or you have functions that return arguments. And since you're the author of the great library KD algorithms, right?
Helped quite a bit by Ivan, but nevertheless.
So you know how many functions inside of that you have that accepts predicates, that accept comparison functions, etc. So all of those are higher order functions. Did you realize that you're writing a functional programming library? So that library, the standard library in C++, which we had since C++ 98, so the first standardized version, all of those libraries have higher order functions in them. So C++ was always to some extent functional.
Okay. And that's where, for me personally at least, I actually come from a functional programming background before I even started in KDAP. And one of the things that I disliked about C++ up until C++ 11 was how, if I wanted to specify a sorting order, the predicate for, or the comparison for this for std sort, then I needed to give it a global function sitting miles and miles away. Okay, I have a big font size, but nevertheless. Or I needed to create an object that was awkward sitting there in the middle, but then came around std function. Did that change a lot in how you see functional programming in C++ too?
So I would say that std function, lambdas, and everything like that eased the way for functional programming to be used by a larger community. Because, as you said, it was quite awkward to create function objects before C++ 11. And now writing lambdas is trivial.
Yeah.
So I would say, well, it didn't allow us to do many more things that we could have done in C++ 98. It did make a lot of things easier.
Okay. As a side note here, in C++, lambdas is square bracket and parentheses and whatnot. We have Unicode. Why not just a regular lambda symbol? That would be so much more awesome to read.
Okay, I'll make a note and submit a paper to the standardization committee.
There we are. Functional programming, as I said, feels more like Haskell, but you claim that, hey, we can do that in object-oriented programming languages too. Is this one of those where you have one camp that goes, we need only do functional programming, another camp saying, no, we should stay with object-oriented programming, another camp doing, well, polymorphism is dead, don't go there? Or how does functional programming fit into all of this?
So first, I need to say that C++ is not an object-oriented programming language. So it's not like we are using functional programming in a completely foreign world. C++ was always a multi-paradigm language with generic programming, with functional programming and object-oriented, and even the C style C++, which, it sends the shivers down the spine. So I forgot the question.
How does it fit in? Will it be one module that is, I mean, we touched a bit on that you do functional programming with std sort. If I was looking at your code, would I see that the pattern in your code was dramatically different from if you looked at my code?
Okay, so, well, the thing that I said, C++ is not OOP, but a lot of people use it as such.
Yeah.
And obviously, especially in, let's say, our little part of the world with Qt, which is really, really, really heavily object-oriented. So sometimes you could say that functional programming is a little bit weird as a paradigm for those people. But from my point of view, you don't need to switch completely to one paradigm or the other. So you don't need to a priori choose whether you're using object-oriented or you're using functional or you're using logic programming. You just learn the tools from all of those paradigms and then mix and match as you wish. Obviously, some things are more easy to mix, some things not so much. If you really like immutable data, then you're going to have a little bit of a hard time in the Qt world. But other things from functional programming, I would say, are quite applicable to any application in the world, regardless of Qt, non-Qt, or whatever it is.
Immutable data, that means data that are completely constant, not being able to change, right?
Yep.
So you're saying I should forget about instance variables and just have functions that can be higher order functions taking parameters and no caching here or there or whatever. This gotta be super slow. Or what am I missing?
I would say you're missing a lot.
Okay. Do enlighten me.
Of course. The world that we are living in, is it slow?
That's a good question.
No, it's not. It's real time, right? So it's a real time system.
Not for those watching it. They are watching it in 1.5 speed. So we are speaking really fast.
So it's even faster for them. So in the real world, we have this moment.
Yeah.
Can we change this moment? No. We are changing the world in the future.
Okay.
Or, if you put it in another way, we are not changing the world. Each second we are creating a new world that is slightly different than the previous one. The previous one is unchangeable, it's history.
Yep.
And you can watch the history as the people on YouTube are going to watch us, right? Mm-hmm. So you have, in functional programming, if you want to go the immutable way, instead of thinking I'm going to change something, I'm always creating new changed versions of the old thing. Mm-hmm. So that's something that is often used in, let's say, sci-fi. When you do something in this world, you're creating parallel worlds. You're creating the world where you did that thing, and you're creating the world where you didn't do that thing. And in functional programming, you can actually model that because the history is still there. All the actions that you perform, you can create parallel worlds. Now, you mentioned, is it efficient? If you're using std vector, it's not, because obviously you're going to, for each change, you're going to copy the vector. But there are specialized data structures called persistent data structures or immutable data structures that can do these things in a really efficient way. And again, for viewers, there is a talk at this conference by Juan Pedro that is about immutable data structures, and he created a library called Immer, which implements really highly efficient versions of the immutable data structures that you can find in, for example, Clojure or some other functional programming language.
I'm not too thrilled that you started bringing sci-fi into this, because every time I watch one of those movies with parallel universes I always end up sitting in a corner pondering about life, and I don't want to be sitting in a corner pondering about life here, so let's continue on. I would say I understand everything that he said up until now, but maybe not. Can you be more down to earth? I want to see some code. I want to get an idea of functional programming in action. What does it look like?
So let's start with something that usually brings people to functional programming.
All right.
And it's historically, you mentioned Lisp, right? So it was a language for Lisp processing.
Open parenthesis, yep. Open parenthesis.
Just forget the syntax. The syntax of Lisp wasn't, it was simple.
It was easy to parse.
It was easy to parse, so simple for the compiler and really ugly for the rest of us. Mm-hmm. But the idea that you have lists or collections in our case, in the case of C++, it will be ranges, and you can chain operations on those collections. So instead of thinking, I need to take the first element and then do this with it, and then iterate, and think of an algorithm.
Car and coulda. Car and coulda.
What?
What? That was the operations in Lisp, getting the first element and the rest of the list.
As I said, I'm a Haskell guy. Lisp is a long way ago, before I was born.
Likely, yeah. Thank you. Yeah. So I just want to the viewers here, there's a number up here. That's my retirement fund. It is set to expire real soon. So yeah, Lisp, and you were talking about functional programming, doing something on the first element, and
yeah, so instead of thinking the algorithm, how to do something, you think about operations that you need to chain for, and you pass the input through those operations to get the output. So I have an example here. So just imagine you have your employees, right? And Christmas is coming, so you need to give presents to young kids of your employees. I'm not sure if you do that. I don't have kids, right? So you have a collection of employees, and you want to just give the presents to those employees, kids that have been with the company for longer than 5 years. You would say employees, then pipe filter, if the employee was with the company for more than 5 years, okay? So the next thing, you want to get children for those employees that you filtered. Okay. You just pipe through transform and say for each of those employees, transform, and you say get children. Okay. What you're going to get is a collection of collections, because somebody can have multiple kids or 0 kids. So you have collection of collections of children, and you want to flatten that into a single collection of children. Yeah. This sounds weird. So you can just call join on it, yeah, and you're going to get a collection of children. And then you can filter them on the age. You just want to give presents to kids that are younger than 2 years old.
Okay.
And you have created a composition of functions that you can apply to a whole collection, and as the result, you get a collection just of the children that you need to give presents to.
That sounds awesome. And I am playing a bit for the camera here, because I, as Ivan told earlier, written a template library about algorithms. So I'm all into this kind of programming. But still, let's talk a bit about performance. I have a raw for loop running through my employees, and inside there running through the children of each employee, doing the test and appending it to the result vector or whatever. Here it sounds like I will be having a lot of temporary lists in between.
Okay, a long time ago I used to answer that question directly. Now I'm going to flip the script a bit. I would say, whenever somebody asks about performance, I would say code readability and safety come first.
Amen.
So, and then in the case of things like collection processing and algorithms, you're expressing your code in a much higher way, so much more readable way, if people know, obviously, the algorithms that you're using. Mm-hmm. And obviously you're going to have safer code, because you're not trying to hit indices, and you cannot have out of bounds reads, writes, and so on. And now I can answer the performance question. In the case of lazy evaluation like ranges do, yeah, there are no really, it doesn't create temporary collections. So when you filter out employees, you're not going to get a vector of filtered out people. You're just going to get something like a smart iterator that knows when you iterate over the collection which employees to skip when it gives you the results. So most of the time you're going to have on-par performance as you would have in the for loop, obviously with some overhead for the smart iterators to operate in.
And yes, I was just giving him a ball that he could smash there, because I'm totally on the same side as you there. The readability of your code is, I mean, if your code is wrong, it doesn't matter that it's fast. And the best way of ensuring that your code is right is to have it readable. I wonder, this is straightforward functional programming. You have a function in parallel to that. Do you have something more exotic that you can explain to us?
So I wanted to show you something that is, I wouldn't say exotic, but something that should be a normal thing to do regardless of whether you care about functional programming or not. So something that often is connected to functional programming and people think that it is a part of FP, but most of the time it's just a good practice to do in any kind of real-world project, even if you have mutable state, you have normal applications with object orientation, right? So it's something that is called the sumtypes, or what C people would call union, but not as ugly as in C. So something like variant in C++, right? And usually when you hear about variant, most of the examples that where you see it used are about modeling JSON, and then you can say variant of int, string, etc. And unfortunately, a lot of tutorials, even in the FP world, focus on that part of the story, which for me it's useful, but it's really not important. It's just a tool for a niche use case. Variants are really important for program safety.
Okay.
To manage the invalid states in your program. Now, I can show you a diagram, although I'm not sure if you can read my handwriting. I can't. So just imagine you have an application that loads a document somewhere from the network, and then it shows the document to the user.
Okay.
So that application, we would usually start by creating a huge class, and that class would have a socket inside, it would have a string for the URL, it would have the buffer where you read in the document, and you would have a lot of member variables about the document.
Don't worry, he's not looking at your code specifically. We all have exactly that code that you're describing there.
And that's an unfortunate thing that you learn early on when you work with object orientation. You create a class and you put everything inside.
Yeah.
As one of the guys from the previous years at Meeting C++ said, classes are the bags that you just shove things in. And that's quite unfortunate, because as the more member variables that you have, the more states that class can have, right? So it explodes exponentially.
Yep.
And now just imagine this thing for opening a document somewhere on the web. When you didn't even start loading the document, there is no point in keeping anything related to the document in memory.
Okay.
Initially, you could split this application into several states. One state would be, let's say, connecting. So you would need, I don't know, a string for the URL, and you would need a socket that you want to make the connection to that URL. Once that you have connected, you no longer need the URL because you have a socket with a connection. So you can just remove that state. And you can just switch to the state that has just a socket inside. When you, obviously, by then, you need to have the buffer where you read in the data. Okay? After you have read everything, you no longer need the socket. So you could say, now I need just the buffer and the document where I would read the buffer in. So convert, let's say, an array of bytes into a proper document for our application.
Yeah.
So again, you can switch to the state that just has those two member variables. Now, when you finished loading the document, you no longer need the buffer. You switch to a state that only has a document inside.
Mm.
So what you have achieved here, initially you could have had something that has a non-empty document, but you're still connected, you're still reading the buffer. That's an invalid state. And if you didn't cover that in your code, which probably you didn't because it's an invalid state, why would I handle invalid states? Then somebody, some malicious actor, could abuse your program in a way to move your program in an invalid state. Your program doesn't know what to do, and then often happens that it can do absolutely anything. And usually anything means running /bin/sh on your system so that they can achieve shell. In the case where you split the states into, split your application state into several classes and put everything inside of a variant, once that you leave a state and move to another state, the previous state is completely destroyed. So when I'm in the document state, the socket no longer exists. The destructor has been called, the socket was closed, etc., without any explicit action from your part. If you had everything inside of a class, then the RAI wouldn't kick in for the socket. You would need to explicitly say .close. In this situation, you don't even need to think about things. You leverage the main feature of C++, which is RAI, to dispose any variable that you no longer need in your application.
Help me out here. I need to see code for my inner eye. Would I then have class my document loader in the private part stood variant less than state 1, state 2, state 3, and then this one would be updated when I move through this loading process? Or
so sure, I would probably not name the state 1, state 2, and state 3.
Oh, come on, you don't call your iterators IT and your integers I and J? What?
So I would probably name the states, let's say, initial state, where we just have the URL. And we have, I don't know, connected state. We could have document loading state and document loaded state. And that document loaded state, if it's a complex application, could again be split into several different states depending on what your application does. If it's, I don't know, just showing the document, then you would have a state, view state. If you can also have a mode to edit the document, then you would also have an edit state. And you would switch between those two. And again, if you're in the viewing state, you don't have any code running for editing. So if a malicious actor comes in, they can't really do anything with your document, right?
There are programming languages out there that I've been told Haskell should be for the new kids on the block here, that are specific about functional programming. And their syntax makes functional programming much easier. C++, general purpose programming, functional included. Is it harder to write functional programming just for your fingers in these languages? Are there anything that we could wish for in the future that would make things easier?
So I would say that in general, Haskell has a nicer syntax, much fewer characters to type. But again, I've been into C++ for so long that I don't really notice the extra typing that happens. The thing where I would really like this C++ committee to move towards, and they're progressing in that regard, is pattern matching, which is a way to do what we currently have to jump around with ifs and inspecting values, inspecting types of values and stuff. And it can be quite cumbersome for C++ people. And it will allow us to have a universal syntax that can at the same time inspect the type of something and parts of its values. So for example, to get back to the kids thing, if you have a collection of persons, of people, and you just want to match if it's a kid younger than 2 years, if it's, I don't know, a female employee for March the 8th, you want to give presents, etc. So you would just, instead of going through if it's a kid and the kid is younger than and etc., you would just have a single construct where you say person, match a person, and then define the match. Kid with age less than 2, what should I do? Female, I don't know, younger, older than, I don't know what should I give her, etc., etc. So it would be, again, a syntactic sugar for something that now we can obviously do, but with a lot more syntax than it needs to.
And that's exactly what newcomers to a language like C++ would expect, isn't it? I mean, people that are new to C++, I've seen them numerous times, they have a switch statement, and they switch over an integer and do stuff, and then they switch over a string, and that doesn't work.
Yeah.
But that would be possible in a pattern matching future, wouldn't it?
Yeah, it would be also one of the benefits for, let's say, less savvy people. Switching on anything and not only on integers and enums would be really, really nice.
Excellent.
Although, I have to say this.
We had this harmony in the room, and everybody was, you gotta say what?
I need to say something that is going to be controversial so that it's a viral moment on YouTube, you know? I generally hate strings.
Oh. Not just people, also strings.
No, just strings. So, if you have a switch on string, then your code design is probably not as good as it should be. Comparing strings, so in general, I don't hate strings. I just hate strings in this situation. If you have switches on strings, you did something wrong in your software design.
Okay. I can take that in. Ivan, we are approaching the last minute. We started out with your book. When I turn a book around, there's always on the back, it's like, this is the best-selling author, and then there's a quote from somebody who wrote the book before it was written. I don't know how that works. And it's like, this is the best book I ever read, and whatnot. What's going to be on the backside of your book?
So there are a couple of quotes on the backside which I don't recall. I know some of the names.
You can get one from me. I liked the first 100 pages until I gave up. Yeah. I don't know why I always only read 100 pages from a book. I got like 1 million books at home, first 100 pages. So
yeah, I'm well aware. I often reply to your questions as, did you read my book? When you ask me something on the chat. So yeah, I'm quite well aware how far did you get into. So I don't really remember those quotes, but the quote that I recall, which was after the book was published, was by Jason Turner. And obviously I'm going to paraphrase. It's not like
and that's this blocked person that is talking about C++ every single week.
Yeah, the C++.
For 500 weeks in a row by now. Yeah.
When he read the book, he said something like, I don't really see why this is functional programming, this is just good C++. And I would say that was one of my points. I could have written an academic functional programming book that just uses C++ as the syntax to demonstrate in, which would be really, really weird. But instead, my main point was for normal C++ people to see benefits and see real examples that they could use in their own world. So it's not a functional book written in C++, it's a C++ book that demonstrates functional programming techniques in C++.
Okay. And I, of course, knew all of this, so I just want to end up here with what he said. Ivan, thank you very much for joining me.
Thank you for having me.